Hi, welcome to my channel Cloud with Girish. In this video, I am going to show you how to build the retro game Space Invaders with AWS Kiro, a GenAI IDE that supports vibe coding and specs-driven development. AWS announced this tool at AWS NYC Summit on July 16, 2025. You might remember my previous build using Amazon Q CLI, where I generated 200 plus line of working Python plus Pygame code in under 10 seconds. While that was amazing, I did not have specs and design for that. Rather, code was directly created by the AI using Amazon Q CLI. With specs-driven development, Kiro goes even further. With Kiro, I not only got the code and working game, I also got specs. It created structured requirements, generated design documentation, created implementation task list, and also created traceability between task and requirements. It also generated the working code task by task. Optionally, it can also generate unit tests. Let's dive into how AWS Kiro transforms GenAI-assisted development. Let's get started. So we're going to look at what is AWS Kiro, how to install it, game overview, review the generated artifacts, which are requirement, design, and implementation task documents, and then review generated code. We'll run the game, see the game in action, and then we'll do a summary. So let's first look at what is AWS Kiro. AWS Kiro is a new AI-powered IDE announced at AWS Summit NYC, and as an AWS community builder, I had the opportunity to work with it before the public release. While many tools support code generation, Kiro goes further by enabling spec-driven development. From a single prompt, it can generate high-level requirements, create design documents, break the design into implementation task list, track task back to the original requirement, and then generate working code for each task, optionally create unit tests. This structured and traceable approach helps build greater trust in GenAI-assisted development, because now not only you have the code, but you also have the documentation around the code that it has generated. Let's see how to install it. So installation is pretty straightforward. If you have installed VS Code or similar IDE in the past, it's very similar to that. So it's forked from VS Code, so it is installed the similar way. You download the software from Kiro.dev, and then you basically install it in your system. Once downloaded and installed, you can sign in using one of the 4 methods provided. So you can sign in using Google, you can sign in with your GitHub account, you can also sign in with your AWS Builder ID, or you can use your organization identity. So let's look at the game. Now this game is not new. If you have watched my prior video on my channel, it's exactly the same game. So it's a full feature clone of the retro classic Space Invaders. It has the arrow key to move the ship left and right. It has the space bar to shoot, and then it has the escape key to quit the game. It got all the standard feature of the game that you will see. The visual style is very retro pixel style, using the simple color rectangle and trying to like show it how it was originally. So let's see step by step from prompt to a playable game with Kiro, right? So open the Kiro, it's an IDE. Once it is installed, simply open it, and then you will see that you have the vibe coding or specs coding. So I'm using these specs, and then you will see an area where you can enter a prompt, and I'm going to enter the exact same prompt that I did with Amazon Q CLI in my prior video and the article. So here the prompt is create a simple retro game Space Invaders using Python and Pygame. That's all. That is my prompt that I'm giving to Kiro. And now what it will do, unlike many other GenAI assisted tool, rather than just creating the code, it generated the specs first. So it will generate the code, but before doing that, I also, because I'm going for specs development, so it generated the requirement. I looked at the requirement, and then once I'm good with requirement, it created the design document. And then again, I review the design document. It's in a markdown language, and then it created the implementation task list. And then for each task, I can generate the code. So the cool thing is that each task is also linked to a requirement. So making it easy to trace back any piece of code to its purpose. So it will generate the code, but you know that for which requirement it's generating that code. That's pretty cool. So I used the same game idea as before. So let's look at like what it did. Now, when I did it in my prior video, I had no specs. I just had 200 plus line of Python code. But here, if you see, Kiro has generated the requirement.md file that has requirement organized in sections in a markdown format. And here is the example of requirement generated, right? So this is just a screenshot from the Kiro, but if you do that prompt that I was showing in the earlier, then it will generate something similar. And if you see here, it's outlining the requirement for creating the game, and then it has come up with the requirement that, hey, like, do this and do that, and when this happens, then do this, and this is the acceptance criteria, and so on. So it's really like, how somebody will write it, but it has saved me from that time, from writing a requirement document. It actually has created for me. Now, once requirements are created, Kiro will proceed to create a design to explain the component that will be used for code generation. And again, here is an example of the design doc created. So if you see here, it's talking about the overview, it's talking about the high level architecture, it's talking about like other aspects of the design. And again, this is just one screenshot. It's much more detailed in this document. But the idea here is just wanted to show you that it's going to create a design artifacts also. Now comes the task. So once you have the requirement and design in a typical SDLC fashion, it's time for the implementation plan. And Kiro has generated the task list for the implementation plan. So if you see here is the example, right? And it's saying start task. So this is the first task. It will set up the project structure, the basic Pygame, and so on. And it's also linking it to a specific requirement from the prior document. I can start this task, and once this task is completed, I can move on to the next, and basically that's how I'm getting my code generated. So these artifacts made me feel as if this entire solution is crafted by a skilled software engineer and not an AI generated solution. And the reason for that is because now I can like relate back to the requirement, I can relate back to the design, rather than seeing hundreds of lines of code that is created by AI. I mean, this one is also created by AI, but the difference is that I have the documentation behind that. So that's pretty neat, actually. So now let's review the generated code, because I did start the task for each of the tasks. So now you can see that it has generated the code. And again, I haven't written a single line of code here. This is all generated by Kiro. I didn't even update it. So ideally, like, when you generate it, you may want to like add your logging and other error block and so on. I haven't done any of that. But if you see it, right, it has created pretty modular code based on each task and created functions, created the rendering, the update and handler and so on. So it's just like, pretty good code actually that it has generated, and it's very modular and structured and so on. So this is the code that we got. So Kiro gave us the specs, like the requirement. It also gave us the design. It gave us the task list, and then it generated the code. Now, once the file is generated, we simply run it using the standard Python command, right? So I'm using Python 3, so my command is Python 3 space underscore invader.py, which is basically the file that contains this code. And if you see it, it worked beautifully, because just like my previous build, but this time I had documentation and a structure to support it. And this is how like the partial screen looks like. And if you see the next one here, then you will see that this is the game in action, right? So this is a functional game. Again, I didn't change the code. It's generated by Kiro. And as you can see that like all the functions of this code are actually working, because, I'm using my left right arrow key, the space bar to shoot, and so on. So really, like, it's really interesting to see that how, like, the GenAI is assisting in accelerating the code generation, and it just keeps getting better. So Kiro is another example of how far generative AI has come from generating documentation to building entire application. While the skills of a software engineers are still required to ensure that code has appropriate exception handling, error management, all the guardrails, follow the best security practices, the use of GenAI-assisted development will improve the cycle time and will help release the software faster, which in turn will help not only meet strategic objective of the business, but will also help validating the demand for experimental features fast. So in this workshop, I rebuilt a retro space invader game using AWS Kiro, experienced a spec-driven development workflow from prompt to code, again using Kiro, reviewed the auto-generated design, task, and Python code, and then saw that how Kiro creates traceability and trust in GenAI-assisted development. Why Kiro over traditional AI tools? Well, you just saw that in action. It created structure requirement, the design component, and plans, and not just the code. So that's a pretty valid reasons to use Kiro. It's easier for teams to review and contribute, because now they know that, hey, there are these multiple tasks and multiple aspects of the requirement and design, and it built in design, traceability, and testing. So honestly, if Amazon QCLI, when I used it to create the same game a couple weeks back, felt magical, Kiro feels like having an AI software architect and dev partner in your IDE, because it's basically doing all those things. I will continue to experiment this, and then I will share more as I learn more. I hope you found this both helpful and informative. I'm constantly creating new content on various AWS topics, so please take a moment to like this video and subscribe to the Cloud with Girish channel. Your support helps me continue producing valuable AWS tutorials and workshops. Stay tuned for more exciting content. Thank you.